Hi all. Today's video we will discuss about the stack data structure. It is a very important concept in the DSA part. You will get lot of questions regarding the stack. So we can move on the stack part. The stack is an I already told you it is a like a data structure where we can use the stack. The stack is a very important part or the vital role in our daily life. For example, if we are arranging a books in a rack like that, so that is also a stack because one by one we are arranging, but the only thing is we need to pick the first one in the first at the what we put in the last that need to be taken the first. So that was the only thing we need to accept in the case of stack. That means last in first out, what we inserted into the last that we need to put in the first time. So here example, the top of the coin, the stack of coins and the stack of plate, we are arranging in a plate and a can of tennis ball, the stack of books. These are the best examples of the stacks representation. For example, I am arranging a book, but first I arrange, for example, you can see here, mm, first I arrange this one, this book, then next one, then blue, these kind of thing. But when I want to, the last one, I need to do the reverse order, then only I can, otherwise it will be like a messy. So the stack of coin, all these kind of operations we can use with the help of stack. So I think hope you all clear about the stack of operators or stack data structures and what are the operation we need to perform with the help of stack. For example, we can consider here this is an empty stack and we need to push the data 1, then again 2, 3. Then pop means we are taking the last item from the stack. So that means the pop item 3 popping out from the stack. So these are the operations available. Empty stack, push, pop. So these are the two operations. Then we need to talk about the applications of stack. So this is I will explain few of the applications here. There are a lot of applications are there. Uh, for example, um, function call. For example, here you can see that the function calls are stored with the help of stack. For example, here this is the program function 1 1. So the function 1 is calling here 1. It is inserted. It is not inserted. Push into the stack function 1. Then inside the function it is calling to the function 2. So next time we can see here function 2 is push into the stack. Then that will calling into the function 3. Then the function 3 is printing a trace of a call stack. That means we need to backtrace. Then once the 3 is completed, coming to the 2, then that pop. Okay, pop, push, pop, pop, then 1. Then it become the empty stack. That is the we need to store all the recursive call with the help of a stack. Then only we need to iterate the n number of times. So that is the best example of stack. And the next one is very important. The evaluation of the infix, postfix, prefix conversion. If you have an example, if you get an example like you need to check these kind of parenthesis check. That is also very important question. So that time also we need to do this help of stack infix postfix conversion. So that also need an extra space that we need to use the stack and the reversing of item. For example, my name is Devi. What I do normally, I push the one by one character, I push into the stack DEVI. When I want to reverse my name, I'm popping first character here I, then V, then E, D. So I get the reverse of the item. So we are using an external, that means auxiliary memory space for this operation to reverse a string or reverse anything. So that is also important and checking the parentheses. For example, um, this is the one. I want to check. I want to check the given parentheses are correct or not. So what I do, first I insert the first one into the stack, this one, for example, this I insert into stack, then checking the closing bracket. So that is closed, okay. And next one I will, this one, right? Then checking next one. This each and every operator we pushed into where the stack and checking. Okay, so this is very important. The checking of the balanced parenthesis is very important. And the another very important concept is the undo redo operation. We are doing the lot of times in our day-to-day life. For example, in a document preparation, we are a lot of time. Sometimes we may make mistake, then we do the undo operation, then redo operation. So that also doing with the help of these stack, because whatever we deleting, okay, whatever we deleting, it is stored in the a stack format, or whatever we are inserting that are stored in a stack, and we redo this back, that means pop and push. So that kind of item is working there. So I think hope you all clear about this stack concept. There are a lot of applications are there. We will discuss more on the time complexity and space complexity in the coming videos. And one more thing I want to tell you, I think hope you all get idea what is stack. And the next question, in the Python, we can implement the stack with the help of list. Okay, normal list. And we are using the collection of DQ. That is also very important. So just want to understand. There are two things we can do. And for example, first one is the using the list. Using the list means we are stack implementation using the list. That is the first one. That means we are creating a variable, that not variable, like a list. Stack equal to list, empty list created, then stack dot append and 2, stack dot append 2, stack dot append 3, and print the stack. So what we get, when I printing this one, I get 1 2 3. Okay, then print dot stack dot pop. Pop means that the whatever item we added at the end, that will pop. So we will get 3. That is this one. The print of stack of pop means I will get the last item whatever I inserted, that must delete from this one. So 3. And top equal to stack of minus 1. And print the top. Top equal to stack of minus 1. Stack of minus 1, whatever in the last item that we get. Here, 3 is already removed, then 2 will be displaying here. 2 is here. Then the length of the stack means 2. In the initial state, it was 3, but when we delete the 3 from the list, the length will reduce to 2. So that is the all idea regarding the stack implementation using the list. And next one is stack implementation DQ. With the help of DQ, we can implement the stack. For example, using the collection of DQ, here what we do, the from collections. From collection import DQ. That is the one we are using. From underscore collection import DQ, where stack equal to DQ. In the previous one, we are assigned to stack equal to empty list. Here, the stack equal to DQ. Then normal function stack dot append, stack dot append. 3 times we append, then 300. This is the DQ we get. So we get DQ of, not list, DQ of DQ bracket of list 100, 20, 200, 300. If we pop the item, what I get 300. 300 is the popping, and top item is 200. And already delete the 300, then the length of the item is reduced to, length of the DQ reduced to 2. So these are the two functions, two implementation using the Python. There is one more implementation is there, but we cannot use in the Python because it is not a multi-threaded environment. For Java, C++ we can use, but we don't want to bother about that kind of thing. So this you want to analyze. Yeah, so we can discuss in the next two videos on more about the stack, and we need to discuss more about in the interview questions also. That is very important. So that I will implement in the next video. Yeah. If you have any doubt, just comment below. Okay.